Hello friends, welcome back to our channel. So today we'll see one more concept in our compiler design, that is a simple code generator. So in our previous session we have seen the representation of a 3-address code, that means the representation of intermediate code generation. So in that we have seen the postfix notation, syntax tree, direct cyclic graphing, etc, etc. And also we have seen in our previous session whatever the issues we need to cover while designing the code generator. So today we'll see a simple code generator. So this is an algorithm which generates the code for the target machine. Simple code generator algorithm. So we need to follow some rules, and see, this is a code generator. The name here specifies generates target code from a simple 3-address code, because so the output of previous phase, that is the intermediate code generator phase, is the 3-address code. So that will be giving input for the code generator. So for the target code we are taking the 3-address code as an input and we are generating the code. So here mainly the two things are very important for this simple code generator algorithm. So one is register descriptor, and another one is address descriptor. So these two things will be used in our simple code generator algorithm in order to know the memory of the variables which are being used in our 3-address code, right? So where the values have been stored, either in the registers or in the memory. So here the register descriptor, the name itself indicates, it will be keep track of variables which are being stored in registers. So we know that register is a one sort of memory with a limited size and a fast access. But the main limitation of the using of registers is very limited number of registers will be available. So this register descriptor will be keep tracking of the variables which are being stored in registers. So some variables will be residing in the registers and some variables will be residing in the memory. Okay, so whatever the variables which are being stored in the registers will be tracking by the register descriptor. And coming to the address descriptor, keeps track of location where the value of variable are stored. So the location where the variables will be stored. Here the term location. So here the location can be either register or memory. Okay, so this is completely register, but here this address descriptor keeps tracks of location, so the variable can be either in the register or in the memory. So these two things will be used in generating the target code by taking 3-address code as a input. Okay, so in order to save the time, I'll write the steps here of this particular algorithm and I will explain the steps, and then we will see a simple example. So this is a 3 steps, mainly the 3 steps involved in the simple code generator algorithm. So what we are saying, so what is the input for this code generator algorithm is a 3-address code, and we have studied that the 3-address code statement will be having at most 3 addresses, that means 3 operands. So any 3 address code statement will be in this format: A is equal to B operator C. So here every operator, every statement operator will be represented in a target language operator. Okay, there will be a separate target language. Okay, so here we'll be calling it as a plus. Okay, so that can be represented as add in this instruction. Similarly, minus can be represented as a sub. Similarly, multiplication can be represented as a mul. Okay, and assignment, so assignment operator, that means is equal to, can be represented as a load. So like this, so every operator in the statement will be having the corresponding target language operator. So these are called the target language operators. So these are all operators which are available in this statement. So we need to use all these things in order to represent the target code generator. So what's the first step? So here we are saying there is a two descriptors, address descriptor as well as a register descriptor. Register descriptor will be uh, having it will keep track of all the registers where the variables have been stored, right? So here first we will be invoking a function called get registers. So we need to know whether the registers are available to store the variables or not, because for example, let us consider we need to perform the operation like A is equal to B plus C. Okay, we need to perform this operation. So we need to store these variables, okay, into the registers or some memory. So for that we need to find, because why we are selecting only the registers means, here by using the registers there will be a very fast accessing. Okay, so for that purpose we are going with the registers rather than the memory. Okay, so here first step is get register function should be called, so that it will be used for identifying whether there are any available registers or not. So if there are any available registers, there will be no problem, we can make use of those registers. And if the registers are not available, automatically we need to find whether there are any variables stored in the registers which are not available, which are not in a use. So if such variables are there, you can just switch that variable values from the registers to the memory and we can use those registers. So see, invoke the get register to determine the location where B operator C should be stored. That means, so here we need to perform B plus C. So we need to find the location, so where the result is to be stored. That can be either memory or thing. So this will be performed in a location. So we need to find out that location by using get register function. So this location can be either a register or memory. Anything it can be, right? Anything it can be. But the first preference will be with the register because of fast access. Next, step 2. So if value of B is not in L, so here L is the result. You can see this is the thing. Okay, so where the operation has been stored. So if value of B is not in L, right? So B is the first operand in the statement. If B is not available in that L, what we have to do? So we need to generate the move function. So we need to move the value of B to the register. Okay, so if already B is available in L, you need not use this one. Okay, you can skip. And if B is available in both location, that means available in both address and memory and register, you need to consider the register only. Okay, so if the value of B is not in L, generate move B comma L. So move B comma L means, so B will be stored in L. Okay, L is the location. Next, generate the instruction operator C comma L. C is the second operand. So here in this example, what we are using, this is a addition. Okay, now what we have to do, we need to add second operand, that is a C comma L. So always remember, if you use this one, so this will be the destination where the value has been stored. Okay, So this implies B value is stored in L. The second parameter or second operand is the target operand where the result is stored. For example, if you use add C comma L, so already L is having B. Okay, in the previous step, B is stored in L. So whatever the value available in L, that will be added with this C, and the result is stored in L itself because this is the destination. Okay, so we need to perform operator C comma L, operator C comma L, and immediately you need to update the address and register descriptors. So which register, that means the register, I mean the way which variables are stored in the registers and which variables are stored in the addresses. So here we are maintaining two descriptors, register descriptor as well as the address descriptor. We need to update them. Okay, and next, if these values B and C values are not in next use, immediately you need to again update the register descriptor and the address descriptor, and we make it ready to switch to the memory because some other variables can be stored in the registers because the registers are limited, only limited, but the access will be very fast. Okay, so these are the main steps involved in this code generator algorithm. So first we need to find the location where the operation should be computed, and the second, if B is not in L, so here there is an option, if B is in L, we can make use of that one. If B is not in L, we need to move that value to the L because we need to find the register, empty register. Okay, and we need to move it. If the register is not empty, so we need to find the variables or the registers which are having the variables which are not in use. So such type of variables we need to move into the memory, and we have to make the registers available for the operations. So if B is not in L, generate move B comma L, we need to move the B to the location. And next, generate the instruction operator C comma L, so actual operation will be done, and we need to update both address registers and the register address descriptor and register descriptors. Okay, so hope you understood the three steps. So just remember these three steps. We'll see one example and we'll understand. See, let us say take these examples. So these are the statements. So we need to generate a code for these statements. So first we can see all these are a three address code based statement because every statement is having at most three operands. Okay, so we need to generate the code here. So initially just imagine the register descriptor is having the registers, all the registers are empty. Okay, there is no variable stored in the registers. So actually that doesn't happen because number of processes will be running in the computer. So obviously the registers will be occupied with the some values itself. But here in this example, let us assume that, imagine all the registers are empty. All registers empty. So here, how many variables are there? So that many memory addresses will be there, and initially all the variables are stored in the memory itself. Okay, so here A, comma B, comma C, comma D, E, F. So all these resides in the memory. Let us consider M as a memory. Okay, M as a memory, and registers are empty. There are no values or variables stored in the register. Right now, coming to the first statement. So we have seen all the registers are empty. Now what we have to do? So invoke get register to determine the location L where B operator C should be stored. So here registers are empty, so we can get the register, one register. Now if value of B is not in L, so let us take R0. R0. Okay, R0 is a register. So B is not available in the register because all the registers are empty. What we have to do? Move this second operand to L. So we need to write move the second operand B to R0. So we are moving the value of B to R0. Okay, what happens? Immediately generate the instruction operator C comma L. So now R0 is having a B, Next we need to apply the operand, operator. What is the operator? Addition. So you can simply write add the operand C comma or not. So already R naught is having a value of B, so that will be added with C, and the result is in R naught. Okay, hope you understood. The result is in R naught. So here the result is in R naught means what is the result here? A. So what is the value available in register R naught? It is A. Now in a memory, the rest of the variables will be residing in the memory. Hope you understood, right? So here add C comma R naught. R naught is having B. C comma B. Addition of C comma B will be stored in A. So here the result is stored in R naught. So R naught is having the value of A. So this happens here. Okay. So I'll write here E is equal to A plus F. D is equal to D minus B. Okay. So now you can see D. Check whether D is available. So first check whether register. So the next register is available and initially the register is empty. So we have to do move, because move the first operand to register. So move here D to R1. Okay. Next immediately we need to apply the operator. So here subtraction. So sub what? What is this? B with R1. So we are subtracting B with R1 and the result is stored in R1. So R1 consists of, previously R0 is having the A and now R1 consists of the result D. So except that one, the remaining variables are available in memory itself. Now the third one, similarly. Okay. So E is equal to A plus F. A is already available in R0. Okay. F is a new thing. So what we have to do? So we can simply move R0 to R2, another register. We are moving just a variable to another register, and addition. So add F to R2. F to R2. Add F to R2. So we should not use the same thing for addition. So we are not using this one because we add simply F to R0. Okay, F to R0, because the value of A will be overwritten. So now R0 will be having E, not A. Okay, so we should not write this. We are using a one more register, that is a R2. So we are moving R0 value to R2 and we are adding F with R2. So now you can see R0 is having A, R1 is having a D, R2 is having E. Okay, here the code is generated and here C, D and F. Sorry, here also D is there. So B comma C comma E comma F. Here also B comma C comma F will be in a memory. Now what happens? So in the reverse process, now R0 is having a value of A, R1 is having a value of D, R2 is having a value of E. But when coming to this one, the result should be stored in A, the result of this statement should be stored in D, not in registers. The result of this value should stored in E. So simply we can use a move operations, move R0 value to A, move R1 value to D, move R2 value to E. Okay, so here you are just finally you are storing the results to from the registers to variables A, D, E. So if you use here R0, F comma R0, A value will be overwritten. So the value can't be stored in A here. Okay, so that's why we are using a one more register here. So we need to take care about all these things. So this is how we can generate the target code from the three address code statements. So here this is a simple example. So any kind of expression, first we need to convert into a three address code and then use this code generator register descriptor and address descriptors to update the variables and to generate the code. So this is a code generator, and we are at every step we are updating the register descriptors and address descriptors. Okay, so here not only the memory, here we need to use this one also, A in register. So here we need to write A comma D in registers, because here we are using a location. Address register means location, right? So here also we need to write A comma D comma E will be in registers. Okay, so that should be updated. So these two should be updated for each and every step, right? So hope you understood this one. And if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.